See, we'll discuss today's session that is very famous name reaction, that is BAEYER-Villiger oxidation. See, oxidation means what actually? See, oxidation means addition of oxygen or else removal of hydrogen. This is called as what? Oxidation. See here, the BAEYER-Villiger oxidation, the very important, what it converts. See sir, the ketones converts to esters by peroxy acids. See, all type of peroxy acids converts to ketones to what? Esters. So let's begin here the reaction and reaction mechanism and moreover applications also. See, first you have to take down this statement, my dear students. Observe careful. See, BAEYER-Villiger oxidation, ketones converts to what? Esters, right? So let's begin our reaction first of all. See, that is pH, C double bond, CH3, C double bond, OH. This is peroxy acid, right? Now, ketones converts to esters. CH3, C double bond, OPH. So this is a major product, esters will form, right? I hope you clear everyone. See, this is very important reaction according to JEE point of view. See, the ketones converts to esters. See here, what is a reaction mechanism? See, mechanism is very important. That is, meg means mechanism. See, first pH, C double bond, CH3, right, plus peroxy acid, here oxygen contains what? Lone pairs. Observe careful, my dear students. Now you have to see, be focused, especially 11th and 12th students. See here, the pi bond breaks. Here, the hydrolytic cleavage takes place. See, that is the reason it gets negative charge, it gets positive charge. See sir, what is the meaning of hydrolytic cleavage? See, hydrolytic cleavage means if bond breaks, the two electrons are shifted towards a more electronegativity atom. That is called as what? Hydrolytic cleavage. I hope you clear everyone. So here what happens? The hydrolytic cleavage happens. So oxygen gets negative charge, carbon gets positive charge. Now here observe carefully. See, this oxygen electrons pair attacks at here. One more point here, what I want to say that, see, one electron pair is nothing but one negative charge. Observe carefully. Sir, why not these oxygen will attack it here, sir? Why? Because these oxygen electrons will participate in resonance. So that is the reason these oxygen electron pair will attack at positive side. I hope you clear everyone. So next step is what? Observe carefully. This is very important step. pH, CO minus, CH3, right? C double bond, CH3, and here hydrogen is present. Now observe careful, my dear students. Be focused here. Observe careful. Here oxygen gets how many bonds? 1, 2, 3. When oxygen gets 3 bonds, oxygen gets positive charge. So that is the reason I kept here positive charge. Alright. Now here again hydrolytic cleavage takes place. See, oxygen gets negative charge, hydrogen gets positive charge. So negative and positive will becomes what? Neutral. Negative, positive will becomes neutral. So my dear students, observe carefully the next step. Here, these H plus will attacks at negative side. Negative side. See, one negative charge and one positive charge will becomes one bond. Will becomes one bond. I hope you clear everyone. Right? Now see here, pH, C, OH, right? CH3, oxygen, C double bond, CH3, CH3. I hope you clear everyone. Now here observe the very important step. That is, what is that important step? Actually, listen careful, my dear students. Here again, what happens? The bond breaks. Oxygen gets negative charge. This oxygen gets positive charge. Heterolytic cleavage takes place. Now here, so what happens? pH, COH, CH3, this is O positive and minus of CH3, C double bond, O minus, right? See here, observe carefully here. Be focus. Now this is very important step. See, now first the bond breaks, phenyl gets negative charge, right? Carbon gets positive charge, right? See, this pH minus will migrate towards the positive side. One negative charge, one positive charge will becomes one bond. That is a very important. See here. Now, what happens the next step? The next step is OH, O, pH, right? CH3. Here the positive charge will obtain. Why? Because this is heterolytic cleavage. So that is the reason phenyl gets negative charge, carbon gets positive charge. Now here, observe carefully here. For our convenience, I will write like this. Right? See, now what happens? The next step again, bond breaks. Oxygen gets negative charge, hydrogen gets positive charge. See, in between adjacent atoms, negative charge there, positive charge there. So what happens? It becomes one, it makes one bond, my dear students. See here, observe carefully here. The negative charge there and positive charge there. See, adjacent atoms, if adjacent atoms, negative and positive sign there, so what happens? It will becomes one bond. My dear students. That is very important, right? Here. So what is the step here? CH3, C double bond, O, pH. See, sir. What happens? The ketones converts to the esters. This is very clear. I hope very clear this reaction mechanism, but it is very important step is there. What is that important step? Observe carefully here. Here the pH there and CH3 is there, methyl there. So why not methyl will migrate here, sir? So why? Because here the pH and CH3 both are there, but pH is migrated towards the oxygen side. So why not methyl group? That is a very important here. Observe careful. See, my dear students. See, why? Because pH only migrates towards the oxygen side. Because the electron rich species migrates first. So in that, in between methyl and phenyl, in between methyl and phenyl, the phenyl has more electron rich. So that is the reason the pH will migrate first. That is very, very important. Otherwise, have to take down here. Electron rich will migrates first. See here. So in that, methyl and phenyl has more electron rich. So that is the reason what happens. The phenyl migrates towards the positive side, right? So this is reaction mechanism, my dear students. Now let us discuss the migrating order, right? Please take down this. See, my dears, next is migrating order. See, migrating order, that is very important. Migrating order. See, more electron rich will migrate first. That is, order is for alkyl groups, that is tertiary alkyl greater than secondary alkyl greater than primary alkyl. Afterwards, CH3 alkyl. See here, one more point, that is H minus. See, H minus is not electron rich, but see, H minus will migrate first, my dear. Why? Because this is exceptional case. You have to remember, right? So now next order, that is para-anisile. Next, para-toluene, right? Next, phenyl. Next, para-chlorophenyl. Afterwards, para-nitrophenyl. So this is a order, my dear students. Please be focused on this order. See, for example, this is NH2, right? CH3. See, in this compound, which one will migrate first? See, sir, observe carefully here. The nitrogen has electron pair. So that is the reason electron pair which contains this group contains, right? So that is the reason this one will migrate first. So here, take down one very important point, that is electron pair will migrates first. See, sir, actually in this both, which one contains the electron pair? The NH2 contains nitrogen contains electron pair. So that is the reason, see, this group will migrate first. You have to remember, my dear students. Now let's next example. Now have to see applications. See here, CH3, CH3, right? CH3, C double bond, CH3, right? in presence of peroxy acid, right? Peroxy acid. So here the which one will migrate first? Observe carefully here. Observe careful. This carbon is tertiary carbon, right? Right. So this carbon is primary carbon. Primary carbon. Observe carefully here. The tertiary carbon has more electron rich species. So that is the reason what happens, the addition of oxygen takes place here. So observe careful. CH3, CH, CH3, CH3, right? Oxygen happens, it will be, see sir, here more electron rich species will migrate first. So that is very important. So this is first application, take down this application. Now second application, see here. Observe carefully here. Peroxy acid, C double bond OH, right? See here this is tertiary carbon, right? This is secondary carbon. This is tertiary carbon, this is secondary carbon. See, according to migrating order, the tertiary has more electron rich. So that is the reason the tertiary carbon will migrate, my dear students. So that is the reason in between C double bond O and tertiary carbon, the oxygen addition will take place. Oxygen addition will take place. See here, have a look. Double bond, right? See here, right? So this is what? Cyclic ester. This is what? Cyclic ester. Cyclic esters is called as what? Lactones. So my dear students, very important step here. This is tertiary carbon, right? So this will be migrates. So that is the reason here the oxygen will insert, right? Oxygen will insert, or oxygen will addition will takes place here. This is what? Second application, right? Third application, you have to take the first you have to take down this. After the third application, we'll see. Next application, that is third application. CH3, C double bond. See, observe carefully here. What happens? Peroxy acid, COOH, right? Now here, methyl group is there, right? Here, tertiary carbon there. So which one will migrate first? See, the electron rich species will migrate first. So that is the reason the addition of oxygen takes place here. Observe careful. So my dear students, CH3, C double bond, C double bond, O, CH, CH3, CH3 will form. So this is what? Third application, my dear students. Observe careful, the electron rich species migrates first. That is a very important, my dears. According to JEE point of view, this is very important reaction. Small recap one. See, BAEYER-Villiger oxidation means what, sir? See, sir, here the ketones converts to esters. That's all. So the reaction mechanism and migrating order and applications is finished. So my dear students, be focused. This is yours, Ravish. Take care. Bye-bye.